Hello, now we'll go with EZ nomenclature. EZ nomenclature is generally given for geometrical isomers where we are having four different groups. If you can't give cis trans, still they are geometrically active, then we go with EZ nomenclature. For example, chlorine, here hydrogen is there, here bromine is there, and here some methyl group is there. You can't say cis or trans. In this kind of cases, we need to go with CIP rules. Can, Ingold, Prelog. Can, Ingold, Prelog rules are very simple rules. Higher atomic number, higher is the priority. If atomic number is more, priority is more. Here chlorine and hydrogen you see, chlorine priority is 1, rank 1. So this is rank 2 available. Okay, there is no need to say this rank 2, rank 1. Okay, now that means obviously the second one is rank 2. Okay, now first rank you mentioned, that's enough. Here bromine and methyl. Okay, now don't look at this hydrogen and all. First carbon, first carbon, bromine higher priority. If two higher priority groups, rank 1 groups are same side, that is Z configuration. Z means you can consider like cis. Cis means same side. Na? So higher priority groups, if they are lying on the same side, that is called Z. For example, if it is given like this, methyl and iodide here, and fluorine and hydrogen here. In this case, if you see, fluorine and hydrogen, all these are empirical, whatever is coming into my mind I am writing, just fluorine and hydrogen. Fluorine is higher priority group. Methyl and iodine is higher priority group. Two high priority groups are opposite sides, so this is called E form. Okay, whatever the name is there, okay, like what we write in cis to butene, trans to butene, like that we can write E and Z. Nowadays for cis trans purpose also we are using E and Z names. Okay, Z means you can say cis and E means trans. I'll give you more complicated examples here. All possibilities of EZ nomenclature examples where students can get some confusion. It is double bond, hydrogen, deuterium, OH, NH2. Consider only for understanding this nomenclature. Okay, now don't ask me how to prepare this compound, right? I think you understand my point. When atomic numbers are same, hydrogen, deuterium, both are having same atomic number, this is deuterium, okay, an isotope. In such kind of cases, the heavier isotope will be getting the priority 1. Okay, now this is the only case we get generally. O16, O18 generally they won't give you. There is a possibility of H and D. So deuterium is more priority. O and N, OH is more priority. Higher priority groups are opposite side. So this is E form. One more example you see. Hydrogen, chlorine, one side I am taking easy. This is priority 1. Second side, this is OCH3, this is OH. First atom is same. When first atoms are same, look at the second atom. This is carbon and this is hydrogen. So obviously this is going to be more priority. If first atom is same, we need to go with the second atom. Okay. Now you see this one. C double bond C. Hydrogen, methyl. Methyl is higher priority group. This is chlorine. This is CCl3. 3 chlorines are there. CCl3. There are 3 chlorines. But there is no use CCl3. Okay, because first atom is chlorine here. Here first atom is carbon. This is priority 1. Higher priority opposite side. So we are getting continuously. Okay. Got it? One more example you see. C double bond C. NO2. NH2. CHO. COOH. If this kind of examples are given, you see. This is carbon, this is carbon. CHO means don't think that H is second, oxygen is third. Not like that. You need to see the structure of this. It will be like this. COOH means it will be having. Now C carbon is first atom same. Double bond O. One side again same. Other side this is hydrogen, this is oxygen. So obviously oxygen will be getting more priority. So this group gets more priority. Here N, first atom is same, second atom hydrogen, second atom is oxygen. So this will be getting more priority. Again we got E. This is also E. Okay, if you want these examples, again see this video. Okay, that will be easy. I am trying to give you all types one by one. This one you see, CHO, CH2OH. Students get generally confused about this kind of points. Chlorine, higher priority. CHO means you need to think this is double bond O, this is hydrogen. CH2OH I said, and this is single bond OH and 2 hydrogens. Now how to consider this? First atom is same carbon. So this point is over. You can't decide with the carbon. Next atom you see. Next atom is hydrogen. Here also hydrogen. Here oxygen is there. Here also oxygen is there. But one more extra hydrogen is there. Don't think in that way. Okay, now this is double bond oxygen. When C double bond O is there, it means carbon is 2 times attached to oxygen. And oxygen is also attached to 2 times carbon. So its meaning is like this better. C double bond O meaning is C 2 times attached to oxygen and oxygen is also 2 times attached to carbon. So C double bond O group means this much big group. Okay, in can in gold prelag rules. Okay, can in gold prelag rules only we need to follow. Okay, now like when you are watching the cricket match, there are some rules. Okay, the rules generally the rules will be in favor of the batsman like that. Okay, such a way. Duckworth-Lewis methods. Okay, all that we are following. In that way, here also we need to follow can Ingold Prelag rules. Can Ingold Prelag rules only you need to follow. CHO, COOH, CH2OH when it is present, CHO gets more priority. But if it is COOH, C double bond OH, if it is there, the CO group is same beta. Now hydrogen and OH group is there. So this gets more priority. Got my point? C double bond O. For example, CN group is there. When CN group is there, CN group means C triple bond N. How to consider the C triple bond N? For example, C double bond C. Now it is CN. CN means C triple bond N. It means, yeah, you are exactly right. You need to think that this is attached to 3 nitrogens. And each nitrogen is also attached to 3 carbons. 1, 2, 3 carbons. 1, 2, 3 carbons. Because C triple bond N. So triple bond, now CN means this much important group according to can in gold prelag rules. Only can in gold prelag rules purpose only. In this way, you need to say the EZ names, majority types I have covered. One more possibility is about this kind of questions. Okay, now you see nothing is here means this is hydrogens. Hydrogens are opposite side, so this is trans. This is also trans, this is also trans. Otherwise, they will give you like this. Hydrogen, hydrogen. Same side, so cis, cis, cis and cis. Otherwise, here one upside going, one downside going, that is higher priority groups, or you can say hydrogen, hydrogen here like this. So this you can say trans, this you can say cis, this you can say trans. Nowadays, in place of trans, they are using E. In place of cis, they are using Z. Okay. So whenever trans comes, you can use their E term. Whenever cis comes, you can use their Z term. So these are also important. Along with this, there is a question about the number of geometrical isomers. Number of geometrical isomers can be calculated by using this formula. For example, it is given to you. Okay. Now you can see this is methyl, this is chlorine. Of course, hydrogen, hydrogen is same. But these ends are not same. This is hydrogen methyl and that is hydrogen chlorine. So the ends are not same. The ends are not same. When the ends are not same, number of geometrical isomers is equal to number of GI, geometrical isomers is equals to 2 to the power of n, where n is the number of bonds, number of double bonds you can say. 1, 2, 3, 4 bonds are there, so 2 to the power of 4. Number of geometrical isomers is equals to 2 to the power of 4 when the ends are not same. When the ends are not same. There is no need to be hydrogen, methyl, fluorine, chlorine, no need. Okay, if they are not same, that's fine. Number of geometrical isomers is equals to 2 to the power of n, where n is number of double bonds. but there is a possibility of getting ends same. Double bond, double bond, double bond. You can see this is methyl, this is hydrogen, this is methyl, this is hydrogen. Like this possibility is there. Now the ends are same. Methyl hydrogen, methyl hydrogen. Don't think that end same should be like this. When it is given like this place is not showing any geometrical isomerism. Two same groups are there, so it cannot show geometrical isomerism. Ends same means two same groups. That may be up and down, that's okay. Okay, now that is only we are counting how many cis trans isomers are possible. When ends are same, then count the number of double bonds. How many double bonds are there? 1, 2, 3. That is odd number of double bonds are there. If number of double bonds are going to be odd, then number of geometrical isomers is equal to 2 to the power of n minus 1 plus 2 to the power, if it is odd number, 2 to the power of n minus 1 by 2. 2 to the power of n minus 1 plus 2 to the power of n minus 1 by 2. If it is odd number, 2 to the power of n minus 1 by 2, because if you are taking n cannot be divided by 2 because that is odd number, so n minus 1 by 2. Here you are using plus, okay, now 2 to the power of n minus 1 plus 2 to the power of n minus 1 by 2. Some books they will be giving you 2 to the power of n minus also they will give here, meaning the answer will come same, but generally I use this formula, 2 to the power of n minus 1 plus 2 to the power of n minus 1 by 2. In this case, for example, 2 to the power of n minus 1 means n number of double bonds are 3. So 3 minus 1, that is 2 to the power of 2 plus 2 to the power of 3 are there. 3 minus 1 is 2, 2 by 2, 2 by 2, 1. That's all. 2 to the power of 2 means 4 plus 2 to the power of 1 means 2. So total number of geometrical isomers will be here 6. 6 are possible here. Now the same one, I am just making a small change here. You see, ends are going to be same only. Methyl and hydrogen, but number of double bonds are now even number of double bonds are there. When even number of double bonds are there, then 2 to the power of n minus 1 plus 2 to the power of n by 2 minus 1. Small difference. Previously n minus 1 by 2, now n by 2 minus 1. Number of double bonds are 4, so 2 to the power of 4 minus 1 plus 2 to the power of 4 by 2 minus 1. 4 minus 1 is 2 to the power of 3, 2 to the power of 3 means 8. 4 by 2, 2 minus 1, 1. Okay, now 4 by 2 is 2, 2 minus 1 is 1, that means 2. So total number of geometrical isomers will be here 10. When number of double bonds are even, when number of double bonds are odd, in all such kind of cases, you can calculate like this. So in this session, we were discussing about EZ nomenclature. When more than one double bond is there, how to find the number of geometrical isomers. Thank you.